Hello, everybody, and all of you awesome people on the internet. I'm Quinn Dunkey, and this is Blondie. Wait, that's not right. Anyway, how y'all doing this evening? I am Joe Stroh-Snyder, and this is Joe's Computer Museum. As you can see, we have a nice, wider, awesome shot here because I have a new camera. You can get the logo in the shot and everything. It's awesome. Let's talk about all the awesome people who are in the chat and got here early. We got Days Vintage, Apple Tech, Rudy's Retro Intel, Michael Mulhern, Thomas Armstrong, Frederic Segar, I think I'm pronouncing that right, Exodium, Joe Williams, and potentially some other people who aren't in the chat yet, but that is okay. So tonight we're going to hang out. We're going to fix some stuff. I got a few client repairs in that I wanted to work on, primarily being this wonderful Mac SE30 board that was bodged together with 18 gauge red wire. Very interesting stuff. The thing is that bodge actually worked. There was nothing wrong with the electrical part of the bodge. Something else went on with that board. So we're going to take a look at that. Also, if we could get that board fixed super quick, then I've got another repair in here from Ron of Ron's Computer Videos. He has a chip that came off of a thingy, a board of some description, that he wants me to surface mount back on there, and that should be pretty simple to do as well. And then whatever else we end up hanging out and doing. Again, thank you all for stopping by and hanging out with me tonight. We've got about 14, 15 of you in there. While you're here, remember to hit the like button on the video if you think I'm doing a good job, or if you think I'm doing a bad job, or if you're here, hit the like button for me. That is super awesome. And if you're not subscribed, subscribe to my channel. I got cool stuff, and I do videos like this, and it's awesome sauce. A wonderful person with what looks to be Japanese characters as a name, and I apologize because I cannot pronounce that. 18 wire gauge is pretty thick. How much current was it carrying? Probably about 10 milliamps. It wasn't carrying anything. The person fixed it with what they had, and it worked until it didn't. So yeah, that's a thing. Channel updates. I've been trying to do more streams lately and less pre-recorded videos because the streams are easier to do, to be honest. I enjoy them more than doing the pre-recorded videos, but that's fine. I do have a pre-recorded video in the works, however, that may get done at some point, about how to clone two-sided two-layer circuit boards for these vintage computers, the process that I use so that I can get that experience is what I meant to say, back out there in the world to other people, so I'm not just hoarding all my brains to myself. Oh my gosh, Ron's Computer Videos is in the chat, and he sends me a $5 super chat. Woot! Thanks, Ron. He says, thank you for your technical expertise, your eagerness to help others, and most importantly, your friendship. Aw, Ron, thank you. And hopefully tonight we can get this SE30 out of the way and get to your board. And if the SE30 ends up taking too much time, I may just put it to the side and get to your board anyway. We will see. Other channel news or other news or news of that description. So if you guys follow me, you might have noticed I've been kind of keeping it under my hat, but I'll get a little bit of an official kind of notification here. I am now an authorized reseller of Blue SCSI units, both the DB25 unit and the desktop unit. So pretty soon as I get parts in and confirm my entire build and packaging process, I'll be putting those on my website. So keep an eye on that and watch my Twitter, which is right down here at Museum Joe, for a notification on when I'm going to be offering those up for sale. So we'll have even more distribution options for Blue SCSI in North America. Frederic Segar says, does that mean you'll live stream GCM1? That would be really cool. I should get that out again at some point and show you all how it works. It's pretty nifty. I have to change my setup here on the bench. It's not quite set up correctly for GCM1, but I could do that at some point. So let's dig into what we got on the bench today. What we have is this SE30 board that was sent to me by a client. Long story short, he said it was working and then SCSI stopped working. and then he did some basic trace repair. He did continuity tests and looked at the schematics, which, I mean, to his benefit, he knows how to do that, so that is really cool. He dug into that and he found that, oh wow, a couple of the lines to my SCSI chip don't work. So he took the board out and fixed those SCSI lines. But after he fixed the SCSI lines, the entire board stopped working. So he got continuity back between the pins on the board that needed to be there, but then the board stopped functioning. So that's what we're going to be looking at tonight. So let's do some screen management magic here. Let me see if I can do this. I need to do, let's do that. Nope. I want to do that. There we go. Here is bench cam. I actually have an overhead camera. Can you imagine that craziness? So let's see if we can get you in here and take a look at this. We'll just do a basic overhead before we dig into the details of what this looks like. Let me see if I can adjust this down for you. Hi, everybody. Zoom, 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 zoomy, zoom. Cool. So here is bench cam. So here's the board the gentleman said to me. And yeah, you can see his big 18 gauge bodge wire here, but it worked. So we really can't complain, and we don't like to we really don't like to trash talk anybody's previous work, because they did the effort to actually try to fix it themselves and do the thing and expand their own knowledge. And it actually worked until it didn't, so no big deal. Ron's Computer News, I just dropped a video today about using the new DB25 Blue SCSI as a support drive for setting things up. You mean like that one right there? Uh-huh, yes, that is a good video. Thank you for putting that out, Ron. So yeah, so basically what they found is there were two lines from the SCSI chip here that were not making it to other places on the board. This line right here is supposed to go to the third pin over here on the 6522 chip. Yeah, 1, 2, 3, the third pin. Now, I have ultrasonically cleaned this because it was gungy. If you saw the thumbnail for the video here, you will have seen that, how absolutely nasty that that board was, especially up in this area here, is pretty yucky. But it fell off during ultrasonic cleaning, so that's a thing. And if you flip it over, there's one on the back too. We've got this trace right here between that point and that point. Now, I took a really close look at this board and didn't really find any busted traces anywhere. But when you disconnect the wire between these 2 points, like is done on the top side, and then you actually do a continuity test between the 2 points, there is no continuity on the board between those 2 points like there's supposed to be. So because of that, there is board corrosion somewhere on this board. Something is messed up. I'm guessing, even though I looked it over very carefully and saw only some flaked off solder mask, I didn't see any actually broken traces. I'm going to guess that the bad traces for in pertaining to the SCSI chip not working are actually under the SCSI chip. So we may whip that chip off and fix it underneath there, or we may just run a surface bodge wire over to here and just connect it up and be done with it. Honestly, that's probably easier to do, but whatever. We shall see. Now, again, I did take a very detailed look at this board with my under the microscope here, and found something very interesting that I think may have been the actual fault with the system here. So let's go ahead and get this under the scope. Wow, you can actually see the scope on bench cam. That's crazy. Let's flip this over here and show you. Translates from Chinese to on the road. My apologies if I said that was Japanese and it actually is Chinese. I apologize. Us Westerners, our letters are very simplistic because we're stupid. So yeah. So let's see here. Let me do a thing. I need to do a little bit of, I'm going to do a little window management on my computer here so I can see multiple things simultaneously, like my stream control window and the chat window and all of that magic. Stand by. So we're going to go to bench cam. We need to go to scope cam with bench. Cool. So Oh my gosh, Brankus Creations, Bruce is here. How you doing, Bruce? So let's take a look at some of this. I'm going to have to refocus the board and refocus the thingamabooble here and move it around. Stand by. Doobie doobie doo. Zoomed out. Focus, 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 focus. So there's their bodge wire with 18 gauge wire, but it's on there. It is on there. There is no problem with that. It's connected really well. You know, I can't really complain about that. So it is Japanese. Okay. Chinese, Japanese. I apologize because, again, American, stupid. Our characters are like 3 lines stuck together, and we are very uncomplex, dumb people. So, yeah. And then this bodge wire was just kind of tacked right there. You can almost see... you can't see that at all. You can almost see kind of where the bridge was connected, right? There's like a little lip here where the connection was, but it disconnected from there. So yeah. And then over here, it's just kind of tacked on. Now, I did check this. Let me see if I can get this in frame really well for you. It's hard for you to see. I did check this, but it is only touching that one pin. There's no bridge in between there. Additional interesting thing, when you're looking at the schematics and the lines that were rebodged together, it's these two right here. It's this one and this one. These two that are the ones that are bodged and moved off to other places. So probably right underneath the chip here, the via is busted. Something's not correct with that. So we will have to see if that's something we can fix here in a minute. But yeah, but as I said, I did a low-level examination of the board, and I'm looking for it here. I need to zoom out. Zoom, zoom, zoom. And we zoom all the way out, and what is that? That is a capacitor that disappeared. That capacitor is gone from the board. It's just gone. And this happens. Bruce mentions this a lot in his chat, in his streams, and it's very important to mention that, yes, there are tiny surface mount components on the back of this board, and you have to be careful when you're moving stuff around, or else you can snap things off the board, which is what happened here. Is this what's actually causing their problem? I don't know. I don't know what this capacitor is, what it goes to, any of that. I do know its value. I did some research and I found the value. And I don't have any surface mounts in stock, but I do have some small, really small through-hole ones that we can tack across there for testing to see if that has anything to do with the machine working or not. So I'm going to go ahead and do that now. Let me get my... I'm not even prepared. My iron's not even on. That's fine. It doesn't take long to heat up. So we're going to go ahead and tack that across there. This is a 10 nanofarad capacitor. So we need to get into the capacitor box and find 10 nuffs. 10 nuffs. We're going to tack that across there. Doobie doobie doo. Doobie 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 doo. Doink. We'll just kind of shove it in there, at least so it's got something in there that's close to the value and capabilities that should be in there, and then we can eliminate that as a potential variable, and then I can order a replacement part on down the road. So let's see, do we have to do any weird lead forming with this? You know, that almost just kind of fits in there. That's pretty nifty. So I just need to kind of bend-a-doodle that down a little bit. Stand by. Let me get my magic bend-a-doodle tool. Bend-a-doodle tool. It's a pair of pliers. And we're going to just kind of bend that down and then back up so that it has a flush contact with the board. Kind of like that. Right? And that way it can lay across the board. And we just can just tack that in place. See? See, I am smart. Cool. So we're going to cut those leads off a little bit. They're a little too long. We don't need them quite that long. There we are. Little itty bitty thing. And we can just tack that in place. Tiny bit of flux to do that. Yeah. I moved the thingy. There it is. Bend a doodle is a very technical term, yes. John Mounts, you're late! But that's okay. The stream's going to question marks. I got a lot of things that we can play with tonight, so it's all good. I got blue scuzzies. I can't put them together because I don't have the parts, but I can show them off. And I've got an HDMI, RGB to HDMI that we could put together. I've got lots of little things we could do tonight. It's all good. Okay. Just live there. Live right there. You can live there. That is, the hole is your home. Are you too good for your home? Oops, I need to turn on my smoke extractor standby. There we go. Okay, let's get this kind of tacked down. Would you stop moving around? Just stop. Just stay in one spot. Stop it. Pain in the butt. Just like live in one spot. There we go. That's in place. So that at least is a temporary fix so we can do testing. Rudy, how you doing, dude? Okay, so now let's flip this over, and we're going to go ahead and just retack this in place that the customer had. So that was right here. Yes. Probably easier to tack it in place this way. Probably. Zoom a doodle. Okay. So it goes on the third pin here. I already looked at the schematic and I know that's where it goes. Yep, that stuff does not want to melt. So let's go ahead and retin this. Better solder. There we go. Retinned. I know it's really funky to just use that that existing wire, but we're going to roll with it. It's already there. We're going to show you, especially if this works, we're going to show you that you don't need fancy wire to fix this stuff sometimes. I mean, it's the right way to do it, but anybody can do it with just about anything. Clean up some of that goo off the pin there. There we are. Okay, let's see if we can get that to tack into place. There we are. That's on there. Doobie, 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 doobie. Let's see. Do you need to remove the gun from between the contacts you just soldered? Good question. No, that is glue that keeps the capacitor in place. If you're talking about the one on the bottom. So we're going to zoom way in here, and we're going to check to make sure this isn't shorted or anything funky. We do have some solder ball gunk underneath here. But that's not, it doesn't look like it's causing any major problem. And I can get the entire tweezer pin through there, so that's not connecting each other. So let's go over here and check this connection. A little better focus. Yep. Now again, that is ever so close, but it is not contacting. It's not at all. See? No contact in there. Probably behoove me to reflow that, but we're not going to. We're going to test it the way the guy sent it to me. Looking at this via hole here, you can't see that. So that's the problem with this camera, is that what's visible for me isn't necessarily visible for you. So yeah, that wire there is only connecting to that pin. So let's zoom out a little bit, it'd be a little easier to see. And this via hole right here looks good all the way through. But this is one of the ones that's on the back side of the board where it's tapped off here and goes down to the glue chip, which indicates that this goes here and straight through, that indicates that, you know, that this via isn't good or something, but whatever. So if you look on the back side, I'm going to have to change the focus. Stand by. Where is it? It's here. Yep. Zoom, zoom, zoom. See, that's that via that is on the top side, right? So there's connection there. So is that an internal board trace? If we look at it, oh, well, it's barely on there. We're going to have to reconnect that, aren't we? Look at that. Uh-huh. So that via, yeah, the trace for this wire is internal. It's in one of the internal layers. So that's what's bad there. There's internal layer failure here. Got it. So I'm going to just play around with this and look at this real quick and examine things. Take a look that this goes here, goes to here, and then disappears somewhere. Connects to the front side, then goes to the back side of the front side or something. Who knows? So let's see if we can. We're going to rerun this with enameled wire, because why not? Okay, that's this one right here. You guys can see that? Yes. Can you focus so they can see it? Yay, focus. Okay. So we're going to get that nice and gooped up with flux. Yeah, there's plenty of copper there, so we're able to connect to that line. That's not a problem. So I am going to, first off, we're going to burn off the enamel here and get the copper exposed like that, because then it'll be able to connect to the via hole here. Burn off the enamel, stick it through the via. There we are. Then we can solder that in place. Maybe. I can get it to take it. Yeah, it looks like it did. I'm going to cut this line real quick. Okay. So we're going to do a little beepy beep test. I know I just moved that camera. Don't worry. I'll put it back. I'm going to do a beep test from the front to the back and see if that connects. That via looks sick. Yeah, but there's copper in it, so we can work with it. If the copper goes away, we can thread down through there. I never understood using enamel when Kynar is available. Enamel's a little bit easier to work with in trace repair functions. This enamel wire that I'm using is 30 gauge. I also have like 34 gauge. I have some super fine stuff here. I'll show it on the camera. Just to show you the size difference here. That's the thick stuff. And next to it is the thin stuff. So I got some of both. I almost never use the thin stuff, but I have it in case I need it. If there's a via that's really, really small that I need to kind of get down through, the thin stuff is helpful for that. So we're going to do a little continuity test. I'm doing this off camera. I know, it's fine. So we got to connect there and here. Yep, it connects to the pin of the chip, so that connects all the way through, no problem. So now we need to route this wire down here. Just do it in a straight line is no problem. And it goes right there. Focus. There we are. Get this disconnected. Oh, I got too many tools over there. Let me move some tools around. Stand by. Doink. Okay. A little bit of flux on that connect-a-doodle there. And just like so. Yep. See if we can get that connected on there. Hot, wire hot. I should probably, I don't know, use my tweezers for this like a smart person and not like a, not use my meat hooks like an idiot. Big fat ape hands. There we go. There we are. Let's try that again. There we are. It's connected now. It's connected, doodled. Cool. The kind art you've been using doesn't suffer from shrink back. Well, good on you. I mean, you can use whatever you want. I happen to use enameled wire. Whatever you like, whatever works. Okay. I'm going to zoom in and double check that, make sure that that all looks okay, and I didn't kill the existing wires or anything. No, I didn't. So we're good there. Cool. So that connects to that. So now we're going to make sure that these connect together. I'm going to put one on here and one on there. Yep. So that connects all the way through. While we're at it, since I had to fix that one, we might as well flip to the other side and fix the other one. Right? Right. Okay. First off, we need to cut this bodge thin here. As a matter of fact, we can just flip it over. That's our bodge wire from the other side right there. We can just press it up directly against that pin and just connect it straight to the pin and eliminate any chance of worrying about that. You guys can't see. See, that's the thing, is like when it's in focus for me, it's not in focus for you. Did the camera lose connection? What happened to the camera? What happened? Stand by. There we go. That was very odd. There, the camera's back. Okay, weird things. All right. So we're going to move this wire out of the way real quick. As a matter of fact, I should probably just remove it. I'm gonna get rid of this one. Yep. Going to connect that to that pin real quick. There we are. Now we need to get this guy right here, and we'll get it prepped. And put a little bit of flux right there, because I'm going to do a little trick. So we need to prep the end of this wire. Prep the end of the wire. There we are. Because then we can do this thing. I'm going to fold the end of this wire over. We can kind of stick it down in here and connect it to that pin. Like so. So a little bit of a turn. Is it in there well? Yeah, it's pretty close. It's a little bit of a twist to it. A little bit of a twist. Fiddly tiny wire, stop moving around all over the place. Stop it. Stay where I put you, please. There That's connected on there. That's good. Might as well add a little bit of solder through this via hole where we ran that wire next to it. It'll take the solder. There we go. Cool. Refill that via hole with some solder. Make good contact in there. Now we're going to pull this up. So I need to zoom down and see if that pin actually connects to that via or not, because it might not be a thing that happens. Checking the chat. Wire wrap wire. Yes, we talked about all that. Is it fixed yet? Retro Techie? No. And no, you can't be an admin just because I know you're going to ask. Will there be a test by fire? We might. Hi, Adam McGee. Can only stop for a few minutes. That's cool. No problem. I'm looking pretty blue. Tom, I am as blue as they get. I am super blue. Yes, sir. Yes. So we're just I'm peeling this back to make sure that there's not actually a via there with that, or a wire that connects this pin to that via. I don't think there is. Super zoom. If I have to, I can look at my SE30 board and look at the same pin. Do this with a little bit differently. Here's my SE30. We're right here. Here's somewhere. There it is. Yes, there is a via. It does connect to that via. So we want to make sure that that stays connected. We're good there. Okay. Cool. So that is cool. Where is it? Let's zoom out here. So you just zoom out, find it, then zoom in. Yep. Cool. So it doesn't matter if that connects there or not. It's fine. As a matter of fact, I think I probably want to connect it there a little bit, only because it makes sure that it fixes any trace damage that might be between this pin and that via. So I need to kind of like get in here at a weird angle to hold this so it doesn't go anywhere. There we are. Cool. Awesome. Super solid. Now let's get this run over to that other pin. Why not? Let's see. I'm going to kind of do this off camera a little bit. Probably want to run it over like this. Like this. Now this board was previously recapped by someone else, not the owner. Someone else recapped this for the owner. But as you saw from the thumbnail of this stream, yeah, the gunge was not cleared from the board. So, yeah, nastiness. So let's take a look-see here. Is pin 3 we need to be connected to. That's fine. Let's go ahead and, you can't see that. There you go. Need to get this out of here real quick. There's my wire. I'm going to put in some of that and put a little bit on the board so I can use the board as a palette, so to speak, to work with it. We're gonna take that wire. Come here, wire. There we go. I'm gonna take that wire and we're going to tin the end of it. All right, just tin the end of that wire. Cool. Wire's tinned. So now I can put a little fold in the wire. You guys can't see that, but there we go. Little fold in the wire so I can get it connected up to that pin. There we are. just like that. So now I need to do a little weird prestidigitation with my tweezers to hold on to that so it doesn't go anywhere. There we are. And we tack it in place. There we are. Bodge fixed. There we got our wires connected, right? So let's go ahead and get this routing cleaned up a little bit. I kind of want this wire to go down through here is what I wanted it to do. That was my desire. Of course, before I send this back to the client, I will clean up this wire and make it like look super pretty and stuff. But for now, we're just kind of getting it out of the way so it doesn't snag on anything. Yep. Let's run down like this. Run down like that. I'll put a couple little tiny dabs of hot glue or something on the board as well to hold that wire in place. But there we go. So we're going to switch cameras so you can see how we ran this wire. Focus. Basically, there's your wire. And we flip over. There's the one on the back. And there's our replacement capacitor. So let's plug it in and see what happens. What's the worst that's going to happen? Nothing. We won't get a ding. Nothing will occur. We'll get SCSI or something like that. We'll see. We will see. We will see SCSI. Ha-ha! Nerd joke. Okay. So let's go ahead and change camera angles again. Change angles to side cam. There we go. So you can kind of see what I'm doing here. I'm using my pumpkin Mac for this because that's the SE30 that I have. Looking at the notes. Negative 19C. Jiminy Christmas. That is cold. It's pretty cold here too. Last time I checked, the temperature was something like 7 Fahrenheit, which is, that's pretty gosh darn cold. -4. Shorts weather. Shorts weather, eh? I've been in -50. Froze up my Apple II. My gosh. So I've got my test set up here. I've got test cables that I have specifically for this purpose so that I can test these boards out of the machine. So that's, we got power, we got sound. I'll get my keyboard and mouse plugged in here real quick to the side. Keyboard and mouse. Keyboard and mouse. 30 people watching. Oh my gosh, I'm popular. Thank you. Thank you, everybody, for hanging out with me tonight. I appreciate it. Currently 43 in Central Florida. John, I'm moving in with you, if that's okay. I'll be there in 6 hours. Okay, so we need to put the customer's memory in this. Memory, customer's ROM chip. This has the plastic tabs on it, but they're better plastic tabs. They're not as quite as crap, so that's good. ROM, RAM, video, sound, keyboard and mouse, machine. Let's flip the switch and see what happens. Anti-static ASMR, yes. Here we go. No bong. I got no beep at all. So that's a thing. Yep, we still got SCSI or horizontal lines. So something is still not quite right with the machine. we're just playing around here a little bit. Checking chips to make sure none are hot. Nope. Interesting. Interesting indeed. Okay. Reset does nothing. Interrupt does nothing. That means it's not running code. Okay. So I'm going to do a couple little things. I'm going to remove the ROM and see if that does anything different. If we get a different pattern on the screen, we do not. Okay. I'm going to put a different ROM in it just to make sure it's not a ROM problem. Stand by. Yep, that ROM's dead. I just dropped it on the floor. Okay, this is my ROM. Should be identical. No difference. No bong. Same lines. Okay. So now I'm going to try RAM. Different RAM just in case. Romblem, if you will. Yes. Try some different RAM in this to make sure it's not the customer's RAM. Of course, getting these apart is always a pain in the butt. Do I have a pokey tool I can do that with? Might make my life a little easier with a little pokey tool here. There we go. Okay. Customer's memory is out. Customer's ROM is back in. I'm going to put my memory in it. Because why not? Give the ROM a really good wiggle when you put it in. Yes, sir. Thank you. Double check this ROM. Really good wiggle. All right. No chime. Horizontal lines. Nice. Okay. So that means we go into double check your work mode. Just make sure that I didn't do anything that broke anything. And get all this ROM out of here just because it's in the way. Or not ROM, RAM. Also, it's mine, and I don't want to leave mine in this board. All right. Doobie, 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 doo, 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 doo. Did you get the pokey tool from Pokemon? Lol. Pikachu! So my RAM is over there. Okay, so let's disconnect the board here real quick, doodles. I'm going to give this a good double check. Put the keyboard to the side real quick. Switch angles so you guys see what I do. We need to go to scope cam with Droid. You love that pumpkin Mac. Thank you. Isn't it adorable? It's not glowing right now because all of the LEDs are in the case, but you know. Okay, let's check this. I don't see shorts between those pins. We're going to check for them anyway. Oops. Make sure this pin does not short to that one. It does not. Doesn't short to that one. Nope. And those don't short. Nope. Okay, no shorts there. I'm going to double check this one over here. No shorts. No shorts. Nope. Okay. I'm going to check this here. Focus. Love that pumpkin Mac. Thank you. What town are you in? I am in, we will just say that I am in Central Ohio. Mac Effects, $1.99, super sticker. Woo! Thank you. Will you be building a Blueberry Mac? You know, that's a very interesting question. I did want to make a super blue Mac. So the phosphor in the black and white Mac screen is technically a very light blue. There are phosphor screens or screens you can find that have the, is it the P11 phosphor instead of the P4 phosphor? Basically, it's a much deeper blue color. It's very deep blue. And that would make a beautiful blue Mac. Do a continuity comparison between your bodge lines and the bad on the board and your working board. Could be off by 1 pin, yes. And that's, it beeps for a second, but that's just the capacitor charging up. There's not actual continuity there. Yep, it's just beeping for a second. Yep. So what did you say? The Macs Joe works on are already blue. Haha, lol. Continuity comparison between your bodge lines on the bad board and your working board. Good test. Let's do that. I'm just going to switch screens for that just because, not bench cam, droid cam. Just because it's kind of hard to do that in the under the microscope for you guys to really like tell what I'm doing, but whatever. So first things first, let's compare these two boards together. I apologize for this noise here. This is a splatter guard that I have taped to my solder thing because if I don't, when I clean this, here it flings solder all over my bench, and I'm trying to stop that from occurring. So first things first. That is pin 3 here, right, to pin 2 there. So we do pin 3 here. That one. Pin 2 here. Yep. So that is supposed to have continuity. And then we have pin 3 on this to some pin on the back. So it's basically just below L8, third pin, this one, to something along there. One, two, three, four, five. 1, 2, 3. Now there's no continuity here on this board. On mine, there's no continuity there. So maybe that's a problem. Interesting. So now I checked the schematic. And in theory, that's supposed to be connected there, but apparently it's not. So my schematic, so I read it wrong, and maybe the schematic is wrong, and so both of us read it wrong. But that's fine. So that means that this bodge wire here doesn't need to be on there. So let's disconnect it and see what happens. I mean, what's the worst that can happen? It still won't work. We're going to go ahead and very, very carefully. 1, 2, 3, 4, 5. Yeah, it's 5th pin. Third pin to 5th pin. Now this, I'm going to kind of just leave the bodge hanging off the side there because it's through the via hole. Just check that. Yep. 1, 2, 3, 4, 5. That's the one I checked, right? 1, 2, 3, 4. Yep. Good catch, John. I appreciate that. So that, and the bodge is kind of hanging off the side of the board there. It's not going to short anything. So let's try that. Why not? That was going to be my next check. Not necessarily that same way, but I was going to actually check the schematic and make sure that that's what was supposed to be, where things were supposed to be connected. Yeah. Okay. So power. Sure, nothing metal underneath there, and that little bodge isn't shortened to something. It is not. Okay. Sound. All right. Let's see what happens. Ha-ha! John, you, sir, are amazing. Good catch. Good catch. So basically the customer's diagnostic was potentially correct, but connected to the wrong spot. So it was causing something to short. Cool. Awesome sauce. Now all we have to do is check and see if the SCSI is fixed, because that is the original thing the board came in for, was SCSI failure. It's trying to boot, but it can't boot. That's fine. So we're going to disconnect this. Plug in my blue SCSI in the back. Turn it on. Oh, I need a keyboard and mouse. That might be helpful. Might be helpful. And power. Ding! I love seeing when things actually work. Yes. Hey, I may have done it, but John Mounts, he had the suggestion of testing that continuity on the original board just as a sanity check, and that is a good check. So extra credit to him. Now, will it boot the SCSI? We'll find out. We may still have SCSI problems. See, SCSI's still not working. So we still have broken SCSI problems. Okay, so let's check to see if internal SCSI works. Let me see if I've got a blue SCSI here I can steal that will do that. I do. Look at that. So let's disconnect that. I need cable. Cable? 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 Where's my cable? What is this cable? That won't work. I know I have a 50-pin cable here somewhere. Well, we could just yank it off the internal one in here. We'll try the internal connector and see if it's just something like that. Okay. There is our internal blue SCSI. Click. Turn it lights up correctly. And it's red, which means it sees an SD card. You can't see that over here, but it is. Are you getting a power light on the blue SCSIs? Yes, I am. No problem there. Yeah, can you see it? Can you see it? See the red light? Red light! Red light! And the blue light isn't blinking. Or is it the red light that blinks? I don't remember exactly. I'm just getting started with figuring out the blue SCSI so I can program them and sell them. Yep, and see, even that doesn't work. It's not doing anything, no access, no nothing, which means the SCSI chip is still having a problem. So now we need to do some more in-depth lookadoodles. Disconnect all the cablages. Move it out of the way. Oh, don't fall on the floor, please. Go over there. Okay. This can go here for now. Let's take another look around this chip. I may have to take this chip off because there could be, connection problems here with other things. I mean, if this wire here had to be done, then who knows what other things have to be fixed underneath or through this chip, right? So we know that wire doesn't matter. So I'm going to just go through here to the other side and clip this off. go. At the very least, if that via was destroyed, we fixed the via by shoving a wire through it. So, I mean, just looking at this, the traces around this chip, they're just not that bad. I mean, they're a little scungy, but they're not like super bad. Where's my scrape tool? Hello, scrape tool. Where did you go? It is gone. It is here. Here's scrape tool. So, you know, we can get in here and look at these. I mean, they all got copper. There's a little bit of modeling there, but it's just not that bad, see? The fact that this one disconnected, though, is suspicious. Why doesn't it connect to the other side? How does that get over there? Does it go through this via, or is there a trace that goes underneath the chip here that goes off somewhere else, right? However, the gentleman who tried to repair this did a continuity test with this, and it didn't go where it was supposed to go, right? So maybe this pin right here still doesn't go where it's supposed to go. So let's figure that out. Where is that supposed to go? So let me bring up the thingy. The schematics. Let's see. Can you guys see my screen? Can we do that? Can I do a magical thing where you can see my screen? Let's find out. Don't resize the window, Windows. Don't be stupid. Be smart. I'm going to put that there. Blink. So I need to go to, we're going to do screen cap right. There we are. You can see my screen. So I want to go, so you can see I've already been looking at this. I believe we want to go to SCSI. Wrong one. We want to go to SCSI page 2, yes. So here, that's the swim chip. 53C80. Here's the chip we want to look at. So the pin that we need to identify on the SCSI chip that is faulty, and I'm just going to count pins that is potentially faulty, is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's pin 9. Pin 9 on here is SCSI IDRQ, right? So we will follow that across here. We need to check pages 3 and 4 right there. 3 and 4. I'd recognize that quote anywhere. Ooh, what quote? Star Trek quote? Where? Where? There are 3 lights. There are 4 lights. Yes. So let's go back and check pages 3 and 4. So it's probably page 3 if I remember. I did look at this a little bit ahead of time. So it goes to the glue chip somewhere, and it's SCSI DRQ. Where's that pin? It's over here somewhere. Right here. It goes to pin 51 of the glue chip. Spirity! Joe, there's a way better SE30 schematic out there, a searchable PDF. Great. You are a moderator. Do you care to drop that in the chat if you got it? So the glue chip is this one, and we need to go to pin 51. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 20. So there's 20 per side. So it's 20, 40, 60. It's going to be over here somewhere. Let's do a little screen change doodle. We're going to do scope cam. Scope cam. You can see me again. So I need to count pins. So it's, for the pin I need is 51, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. It's this one right here. Right there, the one that's shiny. Mac Effects, 99 cents. Whoop! Thank you, Mark, again. These pins look pretty clean. Yes, they do. Pin 51. It is pin 51. I am going to recount these just to be sure. Zoom out a little bit, maybe a little easier to check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. Yep, it's that one right there. Right there. SE30 schematic, thank you. I am going to go into open a new tab. Redraw of the schematic. Thank you, sir. Download. 53 is the last pin on that side according to schematics. Thank you. Thank you. Have a pancake. That is a video gamer reference. This schematic is actually slowing down my computer, and I have 32 threads. That is very interesting. That just goes to show how crappy Acrobat Reader is. Anyway, that's fine. Well, I know what it is, so that's fine. So let's check continuity between these two pins, shall we? I love to count. Two special chips. Okay. I'm going to put one of those there so you can see that it's on there. Make sure it's got connection to the pin proper. It does. And it should, in theory, connect to here. And it does. So there is continuity there. Interesting. I'm not sure why he thought that, but that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, yep, that one's fine. Okay. When did Joe have the wine? Lol. Never. Diet drink tonight. So, let's see here. Now, the SCSI doesn't work. Now, it could be the fuses. So let's just for poopies and giggles, we will just check the continuity of the fuses. Because if these fuses don't work, SCSI won't work. That one's fine. That one's fine. So it's not the fuses. Okay. What could it be? What could it be? I'm just thinking out. I'm trying to think of how far next step I want to take this. I could take the chip off and just check traces underneath the chip, but all the traces look relatively okay. That is an empty via hole. Why is that via hole empty? That's interesting. If I were building a computer to run Acrobat Reader, it would have to be a multi-processor EPIC server, and I'm sure I'd manage to peg all the cores of that too. Why is that? I mean, there's copper there. Why is that via hole empty? It's just devoid. That's very interesting. Does that go to the SCSI chip? No. Goes over to whatever ASC is. Probably doesn't have anything to do with our problem. Let's check. Let's just do some sanity checks here. And then you run Chrome and boosh, the diode. I can check the diode. I have to be in diode mode. That's fine, 0.5 voltage drop. Let's see here. Looking at the schematics, I need to find V1, V2. Where is the SCSI chip? SCSI chip. SCSI chip, SCSI chip. Hello, SCSI chip. Looky, looky, looky. Video interface. Swim in SCSI interface. Here it is. There you are. Mm-hmm. Interesting. Yep. Cool. So I'm just reading the schematic. Give me just hang out with me for a second. Hang out with me and watch it be boring for a long time. It would be really great if the Mac people did what Amiga did with the AmigaPCB.org site. Yeah, that'd be cool. So, and that all goes to the connector. And it all interconnects. I mean, it's possible that that's not connecting. I mean, this is just like super boring check for connections stuff. Pin, okay, well, we can do that. Probably do that off here, maybe. Okay. Pin 1 goes to one. Pin 1's a data pin. It goes to one of these. You know, I could kind of need to be in continuity mode. Yep, that goes there. Pin 2. Pin 2 is a reset line, and it just goes out to the side. Okay. That was weird. My meter was stuck in a mode. Yep. Cool. Pin 3 is a ground. And on pin 3, right? Yep, pin 3. Pin 3 is ground. Yeah, there we go. Yep, we're good there. Pin 4 goes to the external connector. Yep. Pin 5. 1, 2, 3, 4. Pin 5 goes to pin 5. Goes to the connector. Yep. Pin 6 goes to the connector. Yep. Pin 7 goes to board reset, which goes to, it does get connected to a pin on the swims. We can check for that. That's 8530. This is the swim. Okay. So that's 7. One, two, three, 4, 5, 6, 7. This is pin 8. We know where pin 8 is supposed to go, right? Pin 8. 8. 8 is SCSI RQ. We know where it's supposed to go. It goes off the board somewhere. Pin 9, we know where 9 goes. It goes to the glue chip. Yep. Pin 10. Pin 10 goes to a lot of different places. It probably goes to the glue chip. Nope. It's PU. PU goes to a couple different places. It goes to pages 3, 4, 7, and 8. So let's check page 3. 1, 2, 3. PU. Where are you, PU? PU. PU. I'm looking standby. PU connects to a whole bunch of SIM slots. Yep, there you go. Yep, so PU's good. Oh, that was 10. Yep. So it's, what pin were we on? PU. Pin PU is 10. Let's do 11. That's this one here. That goes only to page 3. Page 1, page 2, page 3. SCSI DAC is, where are you? I know you're here. I know you're here. Pin 65 of glue, so it should go here. It does. Yep. Okay. So that's SCSI DAC, which is 11. So we need pin 12. Pin 12 is... Hello, pin 12. I can't see you. Pin 12 is a ground. Yep. 13. Riveting content, folks. Pin 13. 13. 13. Where are you? 13, it goes nowhere. 14 is an address line. Yep. Well, the address lines don't present there. Do they present here? Nope. You gotta present on one of these things. Yep, there we go. So pins 14, 15, 16 are addresses. 14, 15, yep. Go back one. Yep. 16. It's an address line. Yep. 17. This is the last one. 17 goes to SCSI, which is on 3. 3. 3. Page 3. 1, 2, 3, and the line is called SCSI. That is on. Where are you? Probably connects to the glue chip somewhere. Yep, it does. Pin 24, so it's going to be over here. Yep. Okay. So now we graduate to this side. 3 hams will thrill him. 3 hams will kill him. So after 45 minutes continuity test, Joe desolders the chip. Should I just desolder the chip? Is that the consensus? Do you want me to just take the chip off and check it? Because it could be a trace that's inside the board. And if it's inside the board, I'm going to desolder the chip, and it's not going to tell me anything. So anyway, the next line, that one was called simply SCSI, which was this one, 17. So I need to do 18 and 19, which also go to page 3, IOW. IOW is probably on the glue chip. Yep. And the next one is probably on there as well, because that's IO right. Yep. That's good. Could be solder's turned to oxide. Yep. How many layers is this board? I believe it's a 4-layer board. We check those two, 17, 18, 19. We need to check 20, which is a data pin. And those are just data pins. So it's 7 data pins in a row. And those data pins are literally system data pins. Yep. So we check that. That one's good. 1, 2, 3, 4, 5, 6, 7, 8. Well, all the data pins are there. That's pin 28. And now we need pin 29, which is this one, which goes to the connector. Ooh, that doesn't go to the connector. Why not? That is interesting. Interesting. We found a trace that doesn't connect. We did. This is pin 29, right? Make sure it's not pin 28. Yeah, it might be pin 28. Okay. Well, I may have counted them wrong. That's fine. So this one is pin 29. Let's recount them. So we're on that pin. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Yep, 28 is a data pin. So it's 29 we need to check. It's this one here. You can't see it. That one. Yep, that one's got connection. Pin 30. 30 connects to the external connector. 31. 31. 31. 31. Where's 31? Looking for pin 31. 31 is a ground. So 29, 30, 31. 31 should be a ground. Right? Uh-huh. Interesting. This ground has no connection. Note that pin 31 is not connected. It might just not be connected for some reason, but We will continue to investigate. 32 goes to the external connector. Yep. 33. Can't see the screen from here. 33. I might move this over here. Nope, that doesn't work. That doesn't work at all. 33. 33. Hello, 33. Is not documented. Yeah, it is. There it is. 33 connects to the connector. Yep. 34. It's probably connected to the connector. It is. 35 connects to the connector. 36. 36. Meep, 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 meep. 36. 36 is a ground. 36 also does not connect to ground. Just doesn't go anywhere. Interesting. 37 is starting to make my hands hurt. 37 connects to the connector. Ooh, interesting. 29, 30, 31, 32, 33, 34, 35, 36. Was I counting these wrong? 29, 30, 31, 32, 33, 34, 35, 36. Okay, I was counting these wrong. That's 37. It's good. 38. 38. 38. Only 38, please. Thank you. Like, there. 38 connects to the connector. 39, I believe, also connects to the connector. Boring testing with Joe. 39. Yep. 40. 40. 40, 40, 40's connector. 41 is the connector, so is 41 is the connector. 42 is a ground. 43 is the connector, right? Yep. 44 is the connector. Yep. Okay, just make sure some of these data pins don't connect to each other. They don't connect to ground or anything like that. Nope. So that's very interesting. So the SCSI chip has connectivity to effectively everywhere in theory it should. That is very interesting. So it's possible we have a bad SCSI chip. It's possible that we have a bad 6522 because it talks to the SCSI chip to initialize it. Very interesting. Very interesting indeed. Not quite sure how to go about resolving that. Is there a tool? Michael's workshop. I already checked the fuses. Does anybody know of a tool that I can run on a Mac that will tell me if it sees the SCSI chip or not? To see if it can actually comms to the SCSI chip. Whether or not the SCSI chip can connect to something else, I don't care. But whether there's a program I can run that'll tell me if SCSI is working. because if we can find one and I can fit it on a floppy, I can connect this thing to a floppy EMU or something, boot it up, run that check, and it'll tell me if that's functioning. SCSI Director. SCSI Director will actually tell me if the chip is there or not. Okay, cool. So we're going to try that out. I need to get SCSI Director onto a floppy EMU or something, or even a floppy disk is fine. And think about how to do that. I think about where SCSI Director lives. Do I have a copy of it? I think I do. Let's see here. Let me do a thing. We're going to change a doodle. Screens to that. Yes. Okay. Customer's board. Put that to the side. Grab my board. Okay. Make sure we don't have any metal under there. No. Switch to my board. You. You PN'd me a link on Twitter. Thank you. Thank you. Appreciate that. That's that. That goes there. I need SCSI doodles. I need this internal SCSI because it's got. Does it have no, this one does. Yes, this one has my tools on it because it's my external. That's why. Okay, good. Boing! PM'd me on the twits. Morsages. Mac Gardens Transoft SCSI Director. Yes, I have SCSI Director. Thank you. SCSI. I have it on my my DB25 Blue SCSI, which I keep around with diagnostic tools and stuff on it. Doobie doobie doo. Big doobie doobie doo 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 doo. Yes, this case is not a prototype. This is a real production case from Mac Effects. How many people are watching? I still got 29 people watching. You sat there through 20 minutes, 30 minutes of me continuity testing. Wow. They love me. They really okay, stop hamming it, Joe. Stop it. Okay, so, yep, see, I've got this directory here called Tools. And on there, I can, in theory, I've got, like, SCSI Director on there. I've got Tools. Disk Tools. SCSI Director. There it is. Get info. Will it fit on a floppy along with an OS? It might. It may just fit. The upside is I have System 608 here that will definitely fit on the floppy. I think. System folder, file, get info. 1.4. Ooh, tight. Okay, so let's see if we can make something we can use here. So I need to shut this down because I need to connect to my floppy cable. Floppy cable. That's that. That's too short. Do I have a long floppy cable? I do. Look at that. So, floppadoodle. Joe's diagnostic floppy cable for connecting really long things to really long things. I need to get this connected to the actual floppy drive. That would technically go in here, and this is going to be fun. All right, let's see. I know you can't really see what I'm doing here. The angle's weird. Trust me, I'm plugging in a really long boy cable into the floppy drive. There it is. Cool. Like, stop tangling on things and like sit where I want you to. Just sit, just live there. Live there. That's where you live. That's your home now. Okay, so now we can do this. Power switch. Boing! Cool! Can use HD20 mode on the floppy EMU with the SC30. I don't think so. The SC30 I don't think has that mode on it. I can use it on the SC SuperDrive at least. Yeah, but does the SC30, when they went to the SC30, I thought they removed HD20 support from it. I could be wrong. I probably am. That is a comically floppy cable. Yes. This has got to be my favorite. It's just glowing. The board, the main board glows. Anyway. Well, it's reading the floppy drive. Untitled. Is it empty? It's empty. Cool. 1.3 megs available. So I got to somehow figure out how to get a copy of 608 on here and the tool that I need. In theory, I can swap disks and it might work. I don't know. Special file, new folder. We're going to call this system folder. I'm going to do some manual copy and paste and see what's the minimum I can get copied over here. I think all I need literally to boot this is system. System and Finder. Yeah. What are you doing? What was that? No. System. Stop. System. Finder. Copy. You can do it. You can do it. What if you boot off the Raminator image on it and then put SCSI Director on? That's even smarter. I can take this chip out of here and put it in their board. That's smarter. Thank you. I'm doing it now. I'll wait for that. We can just stop it. Yeah, it's fine. Stop. Special erase disk. And just delete it, right? Yeah, we can just do this. Cool. Do that. And then we can close that, do this, and go into tools. And go into tools. Go into disk tools. And do yoink. Doobie doobie doo. Be doobie doobie. But I have to unglue my Raminator because my clips are broken. So I'm gonna have to unglue it. I should just get an extra Raminator just for testing, but yeah, I'm gonna have to unglue it to move it to the other board, but that's fine. That's fine. It's all okay. Can I twist this so you guys can see things a little better? Is that helpful? Can you like focus on that? Can you focus on this? Can you focus on that and stop? Can you stop the rolling shutter? Can you stop? Better, thank you. Give people headaches. Shut down. Click. Cool. All right. So let's switch boards. Undo, 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 undo all the things. Now I've got to deglue my Raminator. and then it just kind of falls out because my clips are broken. They're not actually broken, they're just like splayed out, so they don't hold anything in place. Okay. My board goes here. Customer's board goes here. Raminator goes in. And cables get connected. Doobie. Okay. I'm not going to connect the SCSI because I just want to see if it even detects the SCSI chip, right? So we're going to do that. We'll see what happens. Action Retro Sean, how you doing, dude? Welcome to the stream. If you had to use liquid adhesive to make it work, does that make it glue logic? When the battery leaks, you get fuzzy logic. Yes, yes. ROM disk. 9:30. Been going for an hour and a half now, huh? I don't figure this out. Like I said, if I don't figure this out too super quick, I'm going to switch gears to the other thing that I have going on, which is a board repair, update, fix, hackadoodle thing for Ron of Ron's computer videos. You can boot anytime there, Raminator. Can you sniff the glue logic tip? See, because I'm holding the glue. Get it? Get the joke? Cool. SCSI Pro. Hey, SCSI Pro is on here. Does it do something? Why not? Let's try it. Bus not terminated. Well, that's fine. But it sees the CP. It sees that. Okay. All right. Well, let's try this. Why not? Potato file on Etsy sells ROM brackets. Sold your Raminator place. $3. I have a 3D printer. I can just download something and stick it on there, and it costs me 2.5 cents. I'm not saying the potato file solution isn't awesome, because for $3, that is a great solution. I just have a 3D printer, so I can just do it myself, if and when I feel like it, because I'm lazy and 3D printing stuff bothers me. Like, if it's somebody else's design, it's one thing, but if I have to design my own thing, it makes my brain hurt. Loading SCSI Director. Sees CPU Apple, I would presume that it knows that means it sees the chip. Test. How do I use it? How do I know that this is telling me that it's okay? Joe, I will print and sell back to you any of your own designs anytime you want. Yeah. Like ID search. I presume that because it's showing this, it's showing ID 7. I would presume that means it's seeing the chip. May have to have a device connected. Yeah. So let's go ahead and just go ahead and wow, you can shut down right from the application. That's interesting. Neat. Okay. If you put your blue SCSI on the bus, does it see it? I don't know. That's what we're testing right now. We can't boot from it, and I know that blue SCSI works because we booted from it on that same board or on a different board, just like literally like 6 minutes ago. So. Welcome to Mackie Toes. Clean up my tools while I'm waiting. It's a thing that I like to do. When I have little pauses in my work, I clean up my tools. Keeps the bench relatively uncluttered. The reason being is I have a little bit of an ADHD thing going on, and I'm kind of sort of like a golden retriever. I have no object permanence, out of sight, out of mind. So if I can keep my bench clean and organized, it helps me out. Let's try SCSI Probe since it's right here on here. Why not? Yep, it sees nothing. Nothing. It sees absolutely nothing. Nada. So we can go ahead and try this. We'll try SCSI Director and see what it sees. Where's a good place to find cheap internal 50-pin SCSI ribbon cables for a Mac? Good question. eBay, Amazon. Get yourself bulk cable and IDC connectors and a crimp tool and make your own, which is what I do. Almost any 50 IDC cable work. I mean, literally, yeah, it's right. You can get any. As long as it's 50-pin IDC, it'll be fine. Yep, sees nothing. Nothing at all. So there is... Now, let's think about this. This chip, this SCSI chip, had a pin connected to someplace weird, right? It's possible the SCSI chip got destroyed. SCSI Probe says bus not terminated. Maybe that's where to look. Well, how do I determine that? Educate me, folks. How do I test that termination? It's my understanding that it's the fuse F3 is what sends the power out to the board or out to the connector. And I know all the wires going to the connector from the SCSI cable or from the SCSI chip are there. So that's a thing. Yep, the fuse on the logic board for the term power. That's fuse F3. We already tested that. Hi, Mike, by the way. And fuse F3 was fine. So that is not a problem. I mean, I'll double check it. Might as well. Might as well check it. Shut down. So we need continuity test. Where'd it go? Is it over? Where? See, this is why. See, it's all the way over here. And there's an error with the SCSI controller. Yep, that's exactly what I was thinking. Can you activate the termination on the blue SCSI? It's already there. Well, this one, yeah, this blue SCSI is the DB25. The termination is always on those. So fuse F3 is fine. Fuse F2 is fine. No problems with those fuses. The internal SCSI needs termination. It shouldn't. I've connected boards dozens of times with only using the external connection and nothing connected on the internal, and it just worked. I mean, we can do a test again. We can disconnect that. Got another one here. We can connect this. And this one does have the term power on connected, so that's fine. And it's just going to run off the internal power. I probably should go ahead and connect that just for giggles. All connected. We'll try that. Why not? Now, do you have power going through those fuses? Good point. I mean, you can see the red light. I mean, the thing is on. I mean, it's getting power. There should be power going through the fuses. RAM disk. Check the voltage. Let's see here. We need to be in voltage. We are already in DC volts. I need ground on the ground plane. Ground on the ground plane. Yep. Can you just go back here? Out of my way real quick. Ground on the ground plane. 4.6 volts. It's a little low, but it's there. Yep, there's voltage there. Yep, nothing showing, even though the blue SCSI is connected and it has power on it. You can see the little red light right there. SCSI probe. Nothing. Nada. Bus not terminated, even though we have a SCSI termination power on device connected and whatever. I am thinking that the SCSI chip itself is bad. That's my guess. Is that a good guess? Do you think that's a good guess? I think it's a good guess. It's easy enough to test. I don't have a chip around here, do I? No. I do not have a spare SE30. I'm willing to take... The only SE30 board I have is my own SE30 board. I'm not going to take that apart to test this one. So I would have to order a chip just to see. Yeah, it's nothing. Big, fat nothing. Yep. Mm-hmm. The chip has lost its magic. Is that an NCR 3360 SCSI controller? Swap it. Yep. Mm-hmm. This is a 53C80. I'm sure that they are a dime a dozen on all of the common places. And chip's not hot or anything. I think the chip is bad, or there's just a connection somewhere that is just not there. So, but we have a relatively up-to-date diagnosis. I don't think there's really anything else that I can do with this right now, short of trying to swap that chip. Yeah, so that's where we are. Let's go ahead and disconnect all this stuff. So I think that that's going to be our next step for this client, is to say, hey, I think it needs a SCSI chip. It's going to be a delay while I order a couple chips in. I should probably just order some chips in anyway, just to have chips in stock for repairs. So let's do some cleanup maintenance here. So while I'm cleaning stuff up, to recap, we fixed a broken trace here, which is probably, I don't know how that trace is broken. It's probably busted under the chip. Busted trace. Got the machine up and running because something between here and over here was shorted. And then that led us to discover that the SCSI chip itself is probably bad. It might not be. I think it is. So we could put this stuff over here with that. This is the client's board. Put this to the side. What can we do next? What are we going to do next? I say we fix Ron's board. How's that sound? Does that sound like fun? We got this guy. So let's change camera angles. Camera angles. What's one of those chips to run, I wondered? Yeah, eBay or UT Source. They're probably a dime a dozen, honestly. They're probably not that hard to find. It's not like the CPUs or anything. Processing data. Processing data. I got distracted by things on my screen. What was I doing? I was changing camera angles. That's right. See, I told you I'm a golden retriever. Is this Ron of Ron's Computer Videos board? It is. It totally is. So let's go to Benchcam. Benchcam. Cool. So this is what we're going to be working on. Ron sent this to me. He's like, Joe, can you solder that thing back on there? And I'm like, Ron, we'll try. So this is the chip that fell off. Little surface mount doodle. Fell off, broke off, disconnected, something happened. this is the board that it goes on. Unfortunately, I can't test it because I have nothing that I can test it in. But this is the big honker that it came off of. I don't know what this thing is. I have no idea. It's some sort of video card, it looks like, I guess. I don't know. It looks like the chip came off of right here. Disconnected right there. Yep. Yep, this is a video card. Very much a video card. Uh-huh. Yep, video and a joystick connector. Interesting. Oh, that's neat. Factory bodge wire. Factory bodge wire. Yep. Cool. Look at all these factory bodges on here. Look at that. PC compatibility card, it might be. I don't know. Ron, what is it? What is this card? I don't remember what it is. PC compatibility card sounds about right. Big chip underneath here. Voltage regulator, a whole bunch of RAM. Yeah. Yeah. Sound connect, CD in. Yeah, this is basically a PC. So we need to get that back on there. So let's take a look at the board under your scope. See what the board looks like. Change to scope. Yeah. So we're gonna look at this real quick. Zoom out a little bit. There we go. So, ooh, buddy. Oh, Ron. Ron, you poor guy. Pads are gone, buddy. Lots of pads. All of these pads are gone. That one, now all of them. Now the traces are there, so we can basically shunt a wire across every single one of those, in theory, and get those rebuilt. It's going to take a lot of work, though. Be fun. Show the proper orientation of the chip. Thank you. But I don't need it because what you can see is this corner of the chip is notched, and there's a notch right there. It goes in that direction. Also, I can kind of sort of identify it by the pads that were pulled up. I can see all the pads that were removed. So yeah. Yep. Intel 8242 PC, whatever that does. Okay. And so, yep, there's your pads. Man, what happened to this poor thing? I am sorry, Ron. I am so sorry, man. Wow. Wowie doodles. Okay. Late here, but what are you fixing? Hi, Eric. How you doing? We just finished up determining the SE30 that the stream was to start with is probably a bad SCSI chip. Easy replacement, but I don't have a SCSI chip, so I'm going to have to order one in for the customer. Now we're doing a board repair for Ron's computer videos. Basically, this chip right here got ripped off the board, like massively. Like there are no pads there. Those are not pads. That's substrate. That is a pad right there. Right? That's a pad. That is substrate. It's just gone. It is absolutely gone. I trusted someone to know how to properly ship me a stack of cards. Yep, well, that's where you failed, sir. I'm just doing a preliminary or like a cursory check of other chips just to make sure nothing else looks funky. Look at all those resistor packs. Tons of them. Yeah, I mean, it looks okay. So let's start by cleaning up these pads. Let's get these pads cleaned up. Why not? What else can we do? Just going to clean up the remaining pads and get this as clean as we can. Then we can go about repairing the pads, which may or may not all happen tonight. We'll see. And then we'll put the chip on. Okay, so we just take that and drag that across real quick. And pads are clean. See how easy that is? Magic. Do the same thing here. Clean pads. We'll clean what remains of these pads. And this side has no pads. they're not extant. I mean, I'll wipe this down this way just to kind of clean up the area a little bit, but yep. So now we have to painstakingly take wire and make a pad for every single one of these. Every single one of them. All of them. All of them. Okay. So let's do it. So I need to zoom a doodle in a little bit. Start with this ground pad right here. This is kind of like your Bob Ross moment where you're just scraping, cleaning, and soldering, and scraping and cleaning and soldering for about an hour. Okay, so we need to get down to good metal. That is some thick solder mask. Let me tell you what. Okay. Now this one's even trickier because we have to go on both sides of it. We have to, let me show you. This pad has a connection on both sides, so you have to keep that in, you have to, acknowledge that and have that on both sides like that. Thankfully, my credit counter JCM has lots of headroom. Okay. Scraping, scraping, scraping. It's just hours of scraping. And this one's going to be interesting. What we're going to have to do is there's a via hole here. It's just this fat plane that goes straight to that via. So we'll have to just thread down through that via and connect it on the backside. This is a high quality board. I tell you what, this solder mask is thick. Just does not want to scrape off. It does not want to do. I apologize, this is out of focus for you. When it's in focus for you, it's out of focus for me because it's hard to get the camera and the binocular viewpoint to have the same focal length. Scrape, scrape, scrape. So first, my plan here is I'm going to scrape this all back. I'm going to pre-tin all these areas to make it easy to work with, one line at a time, if that makes sense. So I'm worrying about fewer variables while fixing each pad, if that makes sense. So many lifted pads and no scope. Yeah, I get you. I get you. I understand that. I mean, if this is something you want to get into and do a lot of, yeah, you're going to want a scope. But then you got to set up kind of almost to justify, like if you're going to fix one board, if you need one board fixed, contact someone like me or Bruce, depending on what part of the world you're in. Me, Bruce of Brankus Creations, Steve Mac 84, and have us do that trace repair for you. That one's fine. Because we do this often enough that we're justified in owning the tools to do it. If you're going to do it yourself, it doesn't make sense to try to spend $600 to $1,000 on one of these scopes for that. It's just it doesn't make sense. Now, if you have a reason to have the scope other than that one board repair, then sure, go ahead and do it. And just learn. It's a fun process. So we have all of those exposed. So I'm going to double check them one at a time to make sure that, and this is just an empty pad that doesn't go anywhere, so we don't have to worry about that one at all. We do have to deal with this. And there's plenty of copper there I can just feed through. No issue there. Both sides, single side, single side. 1, 1, 1, 1. Cool. Awesome. Now we pre-tin. And here's a little trick that I use to try to pre-tin this stuff is my solder wick. My solder wick that I've had that has some solder in it is great for just kind of pre-tinning some of this stuff. Because you can just pull and wipe it on down. So I'll put some tin on my iron. Put down a little bit more of the schmoo wherever I put the schmoo squeezy. Hello, schmoo squeezy. A little more schmoo. And you can basically just drag the thing around. Piece of cake. Puts down a tiny little layer of tin without putting too much down, and allows our work to really stick to those pads. Yep. People are asking questions. I don't know, Michael, what question you're asking about sticky tape and which way is up. One piece of tape or two. I don't know. Oh. Yeah, you can solder soaked wick to tin stuff. Yep. It allows you to get a little surface, a little bit of surface tin on there without going too ham on it. Is it fixed yet, Adam? No. We've moved on, Adam. We're in like super crazy mode here. Yep. Okay. So we need more schmoo. You cannot have enough flux. Technically, I guess you could have enough flux, but you know. Okay, here we go. So here's our first one. Okay. one's in place. Next. That one's not on there very well. I don't like that. Where's my pokey tool? Hello, pokey tool. I moved the scope. Okay. Okay, that one's in place. Looks like I knocked that other wire off, didn't I? Oops. Time to do it again. It's really footery stuff. Stop it. Stop moving around. Stop. There we go. That works better. Got to have flux on the cap. Yes. Yes. Okay. Now we got this one. Now this one is one that crosses both sides. So it goes all the way across from here all the way over there. So we need to make sure that we handle that appropriately. I'm just getting the wire in my tweezers here off camera. There we are. Solder on the iron. I almost wonder if the thinner yeah, man. See, that's the problem, is that it is so easy to touch these wires and knock them off. See, I did it twice. Tough stuff. I might need a smaller iron for this. Criminy! Yep, my iron is just a bit too big for this. Are you able to pass the wire into the via and curl it around the other side for more mechanical stability? Good question. Probably. I could probably see if I could get it down through that via hole. It's a very good suggestion. Thank you. First off, is the diameter correct? Barely. I might have to go down to smaller wire to do that. Secondly, these vias are tinted. They're full of solder. So I'm not sure how well that'll work. Doobie doobie doo. Okay. Just to go. I think that this is going to have more stability if we scrape more of that line off there. Think. Just like that. Here's the problem too. Look how close that this wire is really thick. Look how close it gets to that via. I'm going to, for the first time in a very long time, we're going to downgrade to smaller wire. I think smaller wire is going to do better here. Stuff is super thin, but I think it's going to work better in our case. I really do. Take you, kind of hold you down right around there until I can get it with the tweezers. Tweeze-a-doodles. Need some more flux. Okay. Put that on there. Man, I hit this other wire again. God, this is difficult. Difficult. Is that on there? Yep, it's not moving. So let's get this arranged a little better. More solder. There we go. That one's in there. Cool. When you heat this up to attach the chip, what keeps this all from flying away again? Well, that's the trick, is before you do this, before you heat this up, you very carefully go on each side of the wires and all around the wires on the exposed bits behind where the pad is, and you hit that with ultraviolet curing solder mask to tie them in place so that they don't go anywhere. That's what does it. Basically, you glue them down. So tiny bit at the end to keep it from wiggling around, and a tiny bit on the back end here to keep it from moving. And that's it. You can also just, in theory, use super glue. Grab my little itty bitty wire. Stop moving around, wire. Thank you. Get the wire flush to the board. Get it kind of in place there. And ta-da! There. Cool. Did I just yank that right off the board? My finger got caught in the metal, or in the wire, and he yanked it right off the board. Man. Jiminy Christmas. Poopy doopy. My name is Joe, and I'm super grump. There we go. Okay. Doobie doobie doo. Snap, this is live. Yeah, it is. I'm back. Your future mod. What did you miss? Not becoming a mod. Uh-huh. Uh-huh. Conical tip. No, Dave and Sharon. So what happened was this board got sent to us and from Ron of Ron's computer videos. And I'll see if I can show you the chip if I can find it here. The chip that was in this position got literally like yanked off the board. It got like ripped off the board, and all of the pads are still connected to the bottom of the chip. So yeah. Adam McGee, can I be a mod? That depends. Why do you want to be a mod? Do you have a reason to be a mod? Mod squad? Move some of this clean flux down there real quick. I desire it so I can paste links to cool things. What do you want to paste a link to, Adam? Tell me. I need to know. I does have to know. Fingers are getting sticky. A mocker. Okay, Ron. You paste Rick Astley all the time. I just sniffed a rag full of IPA like an idiot. Did you see that? JCM1 store. Well, go ahead and paste that link for me then. I appreciate that. Okay. Now this one is particularly tricky because of its right angle weirdness that we have to deal with here. But we'll see if I can do this freehand. Can we do it freehand? That's the question. Look at that. Look at that. Mm-hmm. Which allows me to now kind of sort of get in here with a weird angle with these tweezers to hold that so it doesn't move all over the place. So I can adjust the position. Look at that. And of course it went all over the place, you stupid. Okay, fine. First things first. We're just going to cut this piece of wire off. Cool. Now it should like lay flat. There we go. That's better. Secondly, if we take this wire and do this to it, bend it in half, bend it in half in this direction. You can do it, and I can hold it. Oh, you poopy. Stupid wire. Stop being stupid. Stupid dog, you stupid dog. You know, Courage the Cowardly Dog? Anybody remember that cartoon? Very, very footery. There we are. Cool. There we are. That's in place. Thank you, Adam. I appreciate that. You could go around to the back side of the via. Yep, I could. But as I said earlier, these vias are tinted and they're full of solder, and I don't feel like trying to clear them out. I really don't. I'd have to get in there with a tiny drill bit and all of that, and I don't want to. Me don't want to do it because I don't want to. Let me get a pokey tool. Pokey tool. Which pokey tool? We'll try this pokey tool. Yep. We'll see how filled those really are. Oh, yeah. Mm-hmm. Yep, those are completely chalk solid. Just not quite sure exactly how I would get that clear. Thanks, John. John Mounts, I was on the Florida Retro Computer Club meeting tonight and plugged the JCM1 lead brake kit. As a great kit to start practicing soldering. Thank you. And you get plenty of practice, too. You get lots of practice because there's like 400 freaking LEDs in the thing. 256 maximum, actually, but you know. Okay, so now we get to try this one. So this is one of the ones where we actually do have to kind of poke the this via out, because the via right here is where all the love is. I'm going to zoom in just a little bit because that's where our copper is, and I got to get attached to that. Is that focused? Can you guys see it? Better for you. There you go. Do you know if there's a replacement chip for the chip on the Apple IIe keyboard? That is a really good question. So, I need to clarify that. Because the Apple IIe keyboard itself doesn't have a chip on it. It's a stupid keyboard. There is a chip, however, on the Apple IIe board. Do I have a solder bridge there? That the chip on the Apple IIe board can have problems. There we go. Yep. And that chip is the AY5 3600 Pro. It's a keyboard encoder chip. And if that fails, you need to get a new keyboard encoder chip. And there's this website called jcm-1.com where you can get a reverse engineered replacement keyboard encoder so that you don't have to go to some weird website and hope the chip is correct and not some rebadged piece of junk, or steal a chip out of a working Apple IIe. Some of those vias don't look like they go to anywhere. I suspect they connect inner layers and may not go all the way through by design. Exactly, right. And so I try not to actually rely on vias like that unless I'm like absolutely certain that they do go somewhere like that. Because this is probably like a 6-layer board, and so they could only go down like 2 or 3 layers and be done, right? So, yeah. Probably, yeah. Hold it this way and then tin it. Yeah, yep, we'll do that. Mm-hmm. Little fresh flux. I may clean this flux off and then add a little more fresh. Dropping things on the floor all over the place. Stop it. Stop dropping things. Okay. Now the trick here is I have to be careful because that pin or that trace right next to that via hole is exposed. I don't want to create a bridge there. I also have to be careful about that one right there, because if I touch that, that'll come flying off. Tricky stuff, tricky stuff. Are. So now I can get my tweezers and get it really pressed down against the board. Hands are a little shaky. There, that's in there. Now I just got to tin this. There you are. Cut it short. Cut it short. Okay. For those of us that enjoy both Apple stuff and IBM or others, why not other name-branded kits? Are you talking about the lead brake kit? It's very interesting you mentioned that, because if you go on my website and look for the lead brake kit, you can buy a custom, how can I put it? I sell the kits with LED packs. So you buy the board, which is the board and the bit and all of the bits other than the lights. And then you can design your own color scheme and just order whatever LEDs you want and order a specific number of LEDs. You can order them in whatever color and design that you want when you place that order. Yep. You didn't realize the keyboard encoder worked on the 3 and also the 2E. My keyboard encoder is magical. It will work anywhere where an AY5 3600 Pro will work. period, also known as the KR9600. It has the default configuration that works in the Apple IIe, the Apple IIc, and the Apple IIc Plus. It also has a pre-programmed configuration that works in the Apple III and Apple III Plus. All Apple IIIs. If you have anything else out there that has an AY5 3600 Pro or KR9600 Pro encoder, it will work on those too, even if you have a custom layout, because the chip is reprogrammable. So if you give me the keyboard matrix, I can reprogram the chip to match any keyboard matrix. It is literally universal. It works on everything. There you go. That's the answer. Doobie doobie doo. Do. So what I'm going to do here on this one is I'm going to tag it here, then bend and bend it, then add more solder. I think that that's probably going to work better in this particular case. Yes. So we need to kind of hold this down here so it doesn't go all over the place, and grab it again with the, well, this, look. Flux held it in place. Okay, that's cool. I can live with that. Joe can live with that. Get out of my way. Alcohol. Okay. It's stuck. It's stuck. So now we can get this properly bent into place. Kind of like that. And then we can solder the rest of it down. Basically used a tiny little solder tack on the far end there as a jig, a forming and shaping jig, to allow me to get it shaped perfectly, see? And then we just tack it down. And now it's on there. Like magic. Cool. Nifty! Doobie-doobie. What I missed is the SE3. Bruce, sorry. The SE30, what we came to the conclusion is that we're pretty sure the SCSI chip on it is toast. We think that that weird connection that it was connected to that was causing the board to just kind of do horizontal jail bars, we think fried the SCSI chip. Because no amount of coaxing of any SCSI connection anywhere or any device anywhere on that makes that thing work. Did I pull that wire off? I pulled the wire off again like a freaking moron. Anyway, like I was saying, no amount of coaxing made that chip work or made anything work on that board. Look at that. Like a freaking idiot. What was I thinking? Yeah, it just, it wouldn't see anything no matter what we did, basically. I forgot to cut the one side of this and just do it. Just yanked it right off the board like an idiot. Okay. Doobie doobie doo. Okay. There we go. That's back up there. You got to cut both sides of the wire, Joe. There we go. Okay. Yeah. We also, before I got distracted by my own stupidity there for a second, Bruce, we also determined that by testing continuity between the SCSI chip and all of the pins on the board where the SCSI chip should go to, we had continuity on every pin. So the SCSI chip has continuity. It's all connected, but nothing will see anything connected to it, either internally or externally. We check the fuse. The fuse is in place. My blue SCSI is connected to either the DB25 port or the external port, or the internal port, I should say. Both get power. So term power is working fine, but all SCSI tools will say that there's just nothing connected. So I'm pretty sure that the chip is probably toast, but the problem is I don't have a spare chip to test with, so I have to get a chip from somewhere and probably get like 5 of them just to have some spare chips. So we've moved on to Ron's thing. Don't know if you were here for this, Bruce, but yeah. So this chip got yanked off the board and ripped every pad off. So I have to manually replace all the pads. So that's what we're doing with this one. Luckily, it was only the pads. So they actually look pretty good. We just got to get things reconnected where they need to be reconnected, and it should be fine. Okay. Yep, that's bent a little too far over, isn't it? Got a spare Mac Classic? Nope. That's the problem. I don't have any Mac Classics at all. My Mac collection is actually quite sparse. I don't have one of everything like a lot of y'all do. I had to, I even had to, I had to take my, here, I'm going to straighten this out. I had to take my pumpkin tosh out just to do the SE. So, because I don't even have a spare SE30. Just the pumpkin tosh. Where is that wire? There it is. There we are. That's better formed. I like that a little better. Let's try that for size. Yeah. Cool. Now I can get that tacked on there better. Got another pair of tweezers to help with this. I do. I got like 18 pairs of tweezers. I only really use like 1 or 2 of them. You guys can't really see what I'm doing, can you? Okay, tweezery doos and tweezery doos. Do. Silent working. Just trying to focus and doing this correct. Microsurgery. I think I can probably work with that. Of course, I just slipped and went all over the place. You stupid, stupid, stupidity stoop. Stop being dumb. Don't be dumb. Be smart. Joe wants you to be smart. Shop smart. Shop S-smart. Wire is just bending and going all over the place, and it's pissing me off. Ah, you mother... Anyway... You have a Junk Mac Classic. You'd be willing to donate the SCSI chip. Well, that's very nice of you, Adam. Give me a yell on one of the other social media platforms we talk on. We can figure that out if you like. We can cross-ship each other things. I have things to send you anyway. Why is this? Stop. Just, like, lay flat and don't be dumb. This wire, I swear, wants to kill me. It wants me to be dead. It just doesn't want to do the thing. Ugh. Sometimes this work is incredibly frustrating. So now this little piece of wire's got too much goop on it. So I got to kind of spread that out and get rid of that. There we are. Dooby-dooby-doo. Morning-ish. Hey, Dana. How you doing? We are fixing an Apple PC compatibility card. The chip got yanked off. I don't know what the chip is. It's an Intel chip of some description. I'm going to try a different angle. I'm going to turn this. And we're going to try it from a different direction. If I do it from this way, and I hold it like here, that'll keep that from moving, and then I can get that tacked down. Like that. There we go. Work smart, not stupid. There we are. I think I can live with that. I think I can live with that. Cool. It's the BIOS or something. Yeah, let's take a look at this chip. What are you? You are zoomed in way too close. Yep. In 8242 PC, and it says Phoenix, copyright Phoenix 1994. So yeah, that seems to me that would probably be the BIOS chip. Yeah, stands to reason. Okay. All right, next pad. downside with this run is I'm not sure if I have a way to test it. What kind of machine does it work in? And what kind of software do I need? Because if I can test it for you before I send it back, that means I can work and test and work and test and work and test until I get it working. Trying to get this aligned just right. Easier said than done. There we are. I've never seen it work. You don't have any other cables that are required, so testing is going to be tough. Yep. Sent you a message about that SCSI chip, so we both remember later. Clicking the button. I see it. Thank you. Doobie 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 doobie. You little out of focus. It's a little out of focus. There we go. That's a little bit better. Is it better for you guys? There you go. Just need to kind of bend this little thing in place real quick. Hold that down so we can tin the wire. Tin the wire. Tin the wire. Do not turn. It mostly stayed in place. And it kind of moved. Stop moving. There we are. Looks good. So we can straighten that out a little bit. Okay. I've never seen it work. However, when I got it, the chip was off, so the chip being on there and there being continuity with the traces the chip is supposed to connect with is further than it's ever been in my presence. Well, there you go. Highest OS you can run on a 2009 Mac Mini? A good question. The one just before Catalina, probably, if I had to make a random guess. It was the one, but just before that, Mac Big Sur, I think. I'm more of a hardware guy. I make hardware work. It's what I do. It's what I've always done my entire career. Software is voodoo. It is voodoo. What works on what? I don't freaking know. Okay. Just need to kind of like hold that down so it doesn't move. So I can grab it from the other side. So I can solder it down. Mm-hmm. Nice solder blob to the via. That's good. That one definitely has a connection. Cool. That one's in place. Quick sanity check across all those. They look relatively good to me. Now I am going to do a quick preliminary, very, very, very careful clean. Just so I can get a better examination of what is going on here. Mountain lion. There you go. I'm going to use cotton swab with a little bit of IPA on it. Just a little bit. Just to get the majority of the goop out. I'm going to change tack a little bit. Go for a direct approach. This brush I'm using, this toothbrush, is literally an extra fine brush. My dentist prescribes me super, super, super soft bristles because I have sensitive gums or something, I don't know. And they're perfect for doing very fine cleaning. Okay. I picked that one up accidentally. Doo-be-doo. Cool. So now we can fix this one real quick that I bent. Okay. And that one. Cool. So those all look like they're in place. This one on the end looks like it needs to have a little bit of that solder ball taken off of it. There we are. Make work a little easier for me. And they're connected on both sides. Yep. Connected. 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 Uh-huh. That's a little loose there. That can use a little bit of a touch-up. It's this one. Yep. That needs to be tacked in place a little better. very, very carefully. There we are. That one's not going anywhere. Nope. And in place. Yep. Cool. How many more left we at? 1, 2, 3, 4. Only 4. Well, cool. I'm going to clean those areas just so I can get a better look. I know I don't really need to be cleaning this up because I'm just going to be re-adding flux to it, but I'm paranoid. I want it to look clean before I start working on it so I can get a good idea what it's going to look like when I start working on it. Yep. So the easiest way to work on that is in this weird long way. Yep. Nope. It's going to be better to do it this way. Yep. That'll work better. Okay. Isopropyl listerine. Sorry, I haven't been watching the chat. This cleaning bit, it's what I watch the vids for. Well, we can do, I can sit here and clean this for hours if you want, Dana. That is fine. You need a special program for 8242? Yes. DOS dude, yes. 2-4 deal. IPA would have to be good mouth. No. IPA, what happens when you drink isopropyl alcohol is your body turns it into formic acid, which then can like kill you. So don't do that. IPA bad. IP bad for you. Okay, so a little piece of wire here. Cool. Cut most of that off. Just make it a little less unwieldy while I'm working on it. Sticky stuff everywhere. Sticky, sticky. Cool. Put a little solder on the iron. And tack the wire down. That's way too much solder on the iron. There we go. That's better. Cool. More flux. There we go. That one's done. I think I clipped it a little bit short. I think I'm going to move that a little bit. Stand by. Adjustments are being made. Need to melt this and move it back just a bit. Like that. There we go. That's better. I like that better. Cool. Make copper tape for pad repair, but you still have to bridge the gap with solder. Yep. Don't pour. Yeah. Auto. Yeah. I'm not really big on using any of those pastes or paints or anything like that for that. Yeah, the LDA. Okay, Dana. Now it's surprising that you know the actual LDA or the LD50 for isopropyl alcohol. You get what I'm imagining. Oh, I see. Yeah, I just saw your comment there, Devalis. I wonder if you could use a press to smash a wire to have pads with leads on them for these kinds of repairs. You probably could. You probably could. I don't think it's really necessary. A lot of extra work. But I mean, if you want to go super fancy, heck, theoretically, I could have painstakingly, because all the pads are still on the chip. I could have theoretically desoldered each pad, super glued it back down, and like bridged the solder, like tried to bridge it back over with a solder blob. No. Nope. Anyway, moving on. Next one. Got things underneath my elbows and in my way, and I can't put my arms where I need my arms for stability, and blah, blah, blah. Complain. What? Wendy Weiner. Okay, that looks good. Looks like I have plenty of flux. Needs to be right about there. Easy peasy. That one's pretty straightforward. Easy stuff. Only 2 more to go, Ron. Only 2 more to go, buddy. Would you like some cheese with that one? Oh my gosh, cheese would be awesome right now. Cheese would be freaking fantastic. I love cheese. Cheese, it's like the chocolate of like savory foods. Yeah, I need flux there. That might be helpful. Sounds pretty good. Pretty good. Although I did kink that a little bit. Let's see if we can unkink it. Yep, pretty easy. Cool. And one more. This one's going to be interesting. So I should probably do it this way. Like that. Yeah. That'll work. Ooh, yeah, let's talk about cheese. Emmentaler is a good cheese. Blue cheese, all blue cheese. Oh, blue cheese is excellent. As far as snacking cheese goes, like just like little chunks of cheese just to eat cheese, I am a fan of a sharp cheddar. I love a sharp cheddar to just munch on. It's just the bee's knees. Or as Marge Simpson would say, I think it's just great. Eh, just trying to get this flat against the board so I can do my thing. Just stop it. Stop moving around and being stupid. Like, go over here like this and do that. I can work with that. There we go. I can work with that. Uh-huh. What other cheeses do you like? What's a good eating cheese? Just for munching, huh? Kind of hard to get bee's knees, yes. I just think they're neat. Nachos with cheese, oh yes. 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 Gosh, now I want nachos. Okay, so that is in place. So now I need to get a piece of this lead like that, long enough, which is to about there. Get that tinned. Yep. Get it tacked down. Sweet. I don't know if you guys can hear me. I'm just mumbling. I don't know how good my speaker or my microphone actually works here. Now that pad's got a little extra schmoo on it, we can go in here real quick and very carefully clean off the schmoo off of just that pad. There we are. There we are. Sweet. And those pads are done. Great. We can hear you. Good. Okay, cool. Yeah, I kind of get a little quiet and mumble. I'm not quite sure what the actual audio levels really sound like on a recording on my new mic here, so I haven't really listened to it too closely. Okay. Get that cleaned up. Dried off. So I can check it for bridges and solder balls and stuff like that. Okay. Now we're going to super zoom and give a really good close examination. Make sure everything looks okay. Is it time for UV solderness? We're getting there. We are getting there. So that one's good. That one is in place. I got a little bit of chunk of solder there. We need to get rid of that. That one's good. That one's good. Yep. Mm-hmm. Cool. It all looks good. So now we need to do a major scrub of this, because when we put this UV solder mask on here, we don't want any of that scunge or gunge or munge or whatever you want to call it on the board, because it'll just prevent the solder mask from sticking correctly. So we do multiple cleaning passes to get it super clean. Pat dry with a paper towel. Okay. I think I'm just re-wetting it with the paper towel, to be honest. Okay. And it's getting there, but it's not quite there yet. We need the appropriate term from Bruce for flux residue. Yeah, see, gunge is capacitor residue. So what is solder residue, huh? What is that? I'm going to use my PCB solution here that I have mixed up. I'm going to clean my brush here on the bench real quick. Really nice. You can't, it's like I'm doing it right down there. I'm getting the brush clean. This PCB solution is 33% isopropyl alcohol, 33% Windex, and 33% ultrasonic cleaner solution. It leaves behind a residue, but the residue itself can then be cleaned up really easily with isopropyl alcohol. Adam, I just bought another Apple IIc. It doesn't matter where you bought it from, Adam. You, sir, are a legend in the Apple II community of buying, fixing, and redistributing / selling Apple IIs. You are well known, sir. So now we're going to use my PCB solution for another cleaning pass. Joe's PCB clean, as I call it. Now it takes it's a little bit tougher for it to dry. It takes a while for it to dry because it doesn't have as much alcohol in it. But that's okay. Cactus, yes. Get that dry. Oops, I bent that pin in the corner. Gotta be careful. Let's get that pin rebent. One more pass with IPA and we should be good. More heat and air. Rebuild your collection of the quadras. That would be neat. I know a guy who's got a broken 840 AV he'd love to get rid of, Dana. There we go. That's pretty clean and dry. Okay. Cool. 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 Now I'm going to run my hot air gun over this at a very low level just to get it dried out. I'm running it at 100. Shouldn't even be anywhere near enough to melt the solder. I pulled that. You see, ha ha ha. Look, looky, looky. Gotta be careful. Gotta be careful. See that one? I pulled that one loose. You can't see jack squat. It's right on the edge of my anti-static mat, so it's getting caught. There it is. See that one? Yep. Gotta be careful. Just drying out all the liquid in these little via holes so that they don't weep up and cause me problems. A lot of this fluid coming up out of these via holes is still flux. So I'll need to clean it again and then... But it's almost there. Still got some solder just kind of sticking around the board here. I need to get rid of. That's gone. Okay. I need to double check that. Stand by. Nope, no contact between those. That's good. That came loose again, didn't it? Sure did. We are over here. Touch that with the solder iron real quick and get that melted back on there. Stand by. This one right here. Where's my bendy ones? Those are a little easier to use. Oh, crap. Touch the one I didn't want to move. There we go. That one's back in place. Just doesn't want to stick, does it? I don't want to put more flux down. I honestly do not. There we go. That's fixed. Okay. Joe's in the same time zone as Florida. I am in the Eastern time zone. Just look at all that slime. It just will not get clean. See you, John. You got to see board cleaning, so you're so happy. I am glad I'm making you happy, Dana. If I made one person on this stream happy, then I guess I did my job. Okay, cool. So I guess now we need to paint. I feel like redoing that one, but I also don't feel like redoing that one. Okay. Goop time! Goes over there. A little bit of paper towel to hold the goop. Doobie doobie doo. Just put a little puddle of it there. It's probably wasteful, but it works for me. You guys probably can't see that on the camera there, but a little puddle of it there on a paper towel. And I get my absolutely tiniest little brush. Here's my little mini brush, but it's even not even it's too big. So, do I have anything smaller that I can work with? I think I do. Stand by. How's that for small? I can use this to just kind of touch the stuff where it needs to be, basically. Try to get this in focus for you guys so you can see what I'm doing. So basically, we're just going to add a tiny little bit of that, either side of that. Ow, I just poked myself with that pokey tool. And it's okay that if I cover the top of this, it's not that big of a deal because I can just take my knife afterwards and scrape the top of it off again. We're really using this kind of as a glue to hold this in place. That's way too much. And that's way not enough. Overdid it, but that's okay. Like I said, once we cure it, we scrape the top of it off. That was way too much, but it's on there now. Just kind of spread it on over. That's fine. Dooby-doo. Dooby-dooby-dooby-doo. Dooby-dooby. No humming. Humming leads to copyright strikes. Gummy bears. Laser pew pew. I don't have a laser. I have ultraviolet LEDs. I have ultraviolet LEDs on a little fixture that I made. Clean that little itty bitty bit up there. Stand by. Okay, cool. I do want to cover all of this trace so we don't have any problems with anything shorting. All right. Cool. So that's all painted up. So we can get my little light and stick it on there. And while that light is curing, then we can look at the chip. Are you using the mask as glue? I am. That is exactly what I'm doing. Maybe I'm missing something, but shouldn't the mask cover the traces, not the pads? Yes. In order to make sure that, basically I'm overdoing it on purpose. I'm getting the solder mask all over everything. Then I'm going to cure it. Then I'm going to scrape just the very top part of it off, just a little bit, just so there's a pad surface, if that makes sense. I saw somebody said second one down is, it looks like, thank you. Good catch. Good catch. It did move in there, didn't it? It's very tenuous in there. It just does not want to live in there, does it? Nothing wants that thing just does not want to stay down. And then put a cherry on top. Yes. Mm-hmm. I may end up redoing that one. We'll see how it cures. We will see how it cures. Okay, so we need to get my little light bulb here. I'll show you the light bulb. My elbow. Click to bench cam. So here's my little light bulb. Right? It's just some ultraviolet LEDs with a USB jack on it, just wired together on the back, and I can just plug it in. Boing. So we just put that over top the chip. We use a pair of helping hands to hold it in place. That's how we do it. So I need to arrange this somewhere so it's off to the side and it's not going to cause me any problems while I'm doing this other part. I think it's going to live right here. It will live right there. You guys can't really see that, but that's where it's going to live, over to the side. Yep. And then I get a little clamp-a-doodle. Hold that in place over top of it so it doesn't go anywhere. That clamp-a-doodle doesn't want to behave. Let's use my little clamp-a-doodle. Go. And it's under the ultraviolet curing light. There we are. And you just sit there and fluoresce. You do you, buddy. Okay. Now, back to bench cam, because we need to fix this chip. Or not bench cam. Scope cam. Scope cam! How many people are still watching? I still got 27 people here, man. Wow, that is cool. Let's see here. I need to click scope cam with bench. There we are. So we need to clean this chip up. Crazy. So let's get these pins fixed if I can. Or at least straightened out or whatever. Okay. Very slowly curving back over. There we are. Okay. Those are back in place. These need to be put back in place now. Those are back in place. Those are already fine. Okay. So now we can fix them up on the bottom here. I think that... Where'd those other tweezers go? I have a pair of flat tweezers. Hello, tweezers. Where'd you go? There they are. These might do a better job. Let's see. I think I want to clean those ripped pads off there before trying to straighten those up. So let's see. Can we do it? Way more patient than you? Dude, this is cathartic. I do this for fun. I'm doing this as a favor to Ron for funsies. Besides, you guys are all here and you're giving me watch hours. So there's reasons. You're helping my YouTube channel and you're helping to tell other people about what I'm doing, which hopefully helps spread the knowledge around. That's the point, really. It's for funsies. I'm doing this more so I can see it more than you guys can because this is pretty fiddly. So I apologize if you guys can't see what I'm doing. Ow. Solder splatter right onto my hand. That hurt. Oh, okay. Sorry I'm being quiet here. I'm just focusing on what I'm doing. You just found your jazz disc while looking for a serial mouse. Is that the serial mouse that I asked you about there, Adam, for that testing thing we were talking about? Interesting question I got for you. Anybody in the chat end up buying the serial mouse from Mac Effects? I would really like to know. Because if you did, well, first off, congrats on you. But second, I'm the one who reverse engineered that for him. If you look on it, you'll see my name on it. We have a couple of very weird reports from a couple of people of some very minor problems with it. So if you did purchase that, if you haven't tested it, please test it when you can and report back to either Mac Effects or to me if you had any problems with it. Because when you want to make sure that everybody gets what they paid for, we want to make sure it works. Now here in my lab, in my testing during design, every single version of it that I put together worked just fine. But there were a couple weird little side, like edge cases that we were worried about. So that's not going to melt because we need flux. Flux. A serial mouse card for the Apple II. Yes, sir, Ron. Absolutely. Since I technically have the design, at some point in the future, I may be able to work out an arrangement with Mac Effects to be able to sell those, but we'll see. I don't want to, I mean, it's his project. He commissioned me for it, so I don't want to just like be stealing his project from him, but yes. Fixing pins, fixing pins, fixing all the pins. Yep, I am going to switch to that pair. Oops. That's a little better. I know you guys probably can't see what I'm doing here. This is very fiddly work. I just have to focus on doing a little more on doing it, a little less on where the camera is. Just fixing pins. Getting them all straightened out. Joe, we need an optical gut swap for the early Mac GS mice. Easier said than done, man. If you really want to do that, I would suggest that you get the Wombat device from Big Mess of Wires. Allows you to plug modern devices into the ADB ports, including optical mice. I helped him test it. This was years ago. There we go. That's about as good as we can expect, I suppose. About as good as that's going to get, guys. It doesn't look as good as using a different mouse. Yeah, I mean, if you go to swap the guts, like you're gonna have to pick. Well, which mouse do we want to swap guts on? Like we just got to pick one, because you can't have one design that works in 20 different mice. It's not how that works. So we're gonna clean the chip. There we are. Gonna dry the chip. Okay. So we're gonna zoom out a little bit. Yep, still needs a little adjustment. It's clean now, but it needs adjustment. They're not quite lined up, are they? Okay. These are good. These require a little adjustment. Hey, Dana, if you're in the chat, if you can hear me, I'm straightening pins. That probably pushes the same buttons as cleaning. Yep, that one went too far. Yeah. I think that's about as good as that's going to get. I don't think it's going to get any better than that. Phoenix. I am still going, Bruce. It's Saturday. Sunday for you, but it's Saturday for me. I don't have anything better to do. And it gets my watch hours up. Helps the channel stay going. Helps YouTube think, hey, people are still there. That still looks pretty soft to me. So we poke it with a stick to see how soft it still is. Still soft. So, come here, wire. Oh my gosh, what is going on with this wire? Wire. You can do it, wire. Yeah, my solution of hardening this stuff isn't as fast as using a laser because, yeah, these just aren't putting out that much light. They're not that bright. I know you can't see. That's fine. Would a grow light work faster? It might. Just getting it right down on top of that, right there. Uh-huh. Yeah, we're good. I have something that might work faster, actually. Is it in the room? Ow, I just stubbed my toe. I stubbed my toe on your box, Ron. Pretty good 10-watt UV lamp recently. Happy to send you a link. Sure. No problem. I do have a really cool thing I can use for this, though. I'm just seeing, it might be up here. You guys can't see. It might be up here on one of my shelves. It might also be all the way over in the garage. I think it is in the garage. So you guys are going to go on hold for a minute. You're going to go on hold. You're going to go on hold while I go fetch it. Here, look at stuff over there. Do that. I'll be right back. And I am back. I have returned. So, here we go. This is a nail polish curing lamp used in salons. I actually got it from a salon supply. It's got 4 big freaking light bulbs in it. This right here is while Joe's OBS build-out needs a waiting room tab with Mocious graphics and a jaunty song. Yes, I know I need that. I need that. The way I'm, what the heck? Hold on. My camera mount is sitting on something weird and it's bothering me. There we go. That's better. So, processing data. Yes, I am aware of that, Ron. I do need a little thing. I do have a video. I can actually play it right now, which is this. But you can't hear any sound because of the way that I'm streaming using StreamYard. I'm using OBS to control my scenes and my layout, but then I'm using StreamYard to actually do the streaming because it's easier. I could, just click a button in OBS and stream directly, but I don't. Anyway. So we can go ahead and change to super lamp here. Let's go and do the bench cam. Bench cam, yada yada da. Jaunty music, Joe. And bye. I'm just trying to get you guys a good angle of what I'm doing here. You can see my huge belly in the shot. Cool. So basically, I can do this. Put the board there. Get my little mini UV light out of the way. Probably put it like this. Stuff, cables, wires. I got more wires in here than AT&T. And then what we can do is we can just put that whole thing right over top of it like that. See? See? Just fits right over top of it, like a champ. So let's plug it in. Just have to be careful not to stare directly at it, of course. It is in infinite mode, and we turn it on. We do that. Is it running? Lights are on. They're glowing. We're just going to stick that on there, and we're going to wait a little bit. By law, your away music has to be 4 times the volume of the original stream. Sing us jaunty music. No. What about the cat video? I don't have a copy of the cat video. That'd be hilarious. That would be funny. Can we go to Droidcam? I'll give you a better... idea of what's going on the bench. Just got the lamp there and it's cooking away. Don't stare into the light. It's oh so pretty. Zap! It's the same light, actually. It's exactly what it is. Make sure that I can't see that light so I don't have any, flashback reflection of UV. Of course, it's going to start to smell a little bit like ozone in here in a little bit, but that's okay. Computer, Arch. That weird noise that they used. That stock footage sound they used. Okay. I'm going to, like I did earlier, I'm going to clean up a little bit while I'm in a pause mode. It's a thing that I do just to keep things, because as you work, you just clutter. It gets cluttered more and more and more and more, and before you know it, your desk is like 80 parts tools and 1 part desk. Oops, I moved that. I didn't want to. Cleany, cleany, clean. Organization. Cool. Green nail polish to make this thing. Don't tempt me. I actually have some. I just finished retrobranding a set of white key Apple IIe keycaps. They look frickin' awesome. Yeah! Yeah! My clear case Apple IIe has white keycaps. It works perfectly. The Catrix. Cat video. Madman Dark Jedi. So if you don't follow either Mike's Mac Shack or the Maciac folks, you probably won't know what that video is. Basically, Mike's Mac Shack he owns like 8 cats. And there's this like background shot of him while he was live streaming, and one of his cats was climbing on the desk and just like fell right off the desk like an idiot. And now the Maciac folks use that as an interesting little segue. They're like, okay, next topic, and then they'll play the cat video. So that's a thing that they do. Oh man, I love some B-sci-fi movies that use sounds from Doob. Yeah, that noises and Mike's Cat Shack. Yes. So this thing is much more powerful than any other UV light. So we're going to turn that off real quick. And that's probably done now. So I'm going to check this. I'm going to poke it with a stick. Nope, it's still a little soft. I mean, the top of it's hard, but the gooey center is still soft. So I want to make sure that gets completely done. Yeah, I got UV solder mask all over everything. Nice. The cat was okay, for the record. Yeah, cats are resilient. I mean, you've seen videos of cats falling off like 15-story buildings, landing on their feet and running away. So now just cleaning up the gobs of UV solder mess that I somehow got all over the bench. I don't know where it probably came from, that spool that was sitting over here to the side, and I probably got my hand in it somehow. How are we all doing this evening, everybody? We all just hanging out and having fun this evening. Herb, how long have you been here? And how are you? And will I see you again at the next Kansas Fest? Chocolate-covered cordial cherry. Yeah, that'd be good. If the mask is so thick, can the UV penetrate down that far to cure it? I don't know. No idea. We're trying it. If it doesn't work, I'll yank it out and doing whatever. You've been here for a couple hours? Really? Man. Okay. Doobie-doobie-doo. That may be to be determined. Yeah, I know. Kansas Fest is What's going to happen, man? You know? Oh, wow. Oh, it's getting late. Still 26 of you sitting here. This is crazy. If it's anything like UV curable resin, yes, it can get down to it. Yeah, I don't think we're going to have a problem. It's going to just take a while because it's thick. I'm really curious about my stream. I'm gonna go look at my stream data. I'm really curious to see stuff about it. So let me click a button. I'm watching the stream, listening to my cat complain that she can maybe see the bottom of the bowl. Yeah, it sounds about right. That sounds about right. Mm-hmm. Yep. Yeah, it's been tailing off a little bit here, but I've been consistent about 30 viewers all night. That's amazing. Cool. Check this again, because now we're literally in the watching paint dry part of the stream. It's getting there, but it's still quite gooey underneath. That bothers me. Okay. Well. Cure, damn it. Cure. Just want to get this as close as possible to the actual light. Yeah, don't stare at the UV light, you idiot. Yeah, it might be bad for your health. Your eyeballs. Just sit down on top of that. And I somehow got solder mask on me again. Bad night time for me tonight. Good night. Good night, Joe Williams. Pleasant dreams, sir. What the hell is the world coming to? Who knows? Who knows? I thought you were a little taller on the radio. That's funny. Oh, I'm getting sleepy. It's midnight now. Oh my gosh. So here's the question. Here's the question. Do we want to sit here and watch UV stuff cure, or do we want to come back later? Maybe tomorrow night. Maybe tomorrow during the day. I don't know. Might just randomly start a stream and finish this off. Because I still got to finish the SE30 and figure out something that, well, I don't have a chip for that. Right? And this is just waiting for this UV to, I have no idea how long it's going to take. It might be done in another 10 minutes, or it might take another 3 hours to fully cure. I don't know. But I think it's sleepy time. It's sleepy time for Joe Guy. Besides, I got a couple TV shows I want to watch tonight. And it's just kind of, we're kind of winding down. I'm at what? Gosh, I started at 8. It's what, 4 hours? Yeah, we should probably close this down for tonight. So, well, where did we leave it off? We had an SE30 that wasn't booting, that we ended up getting booting up. SCSI still doesn't work, but we're pretty sure the SCSI chip has failed because of the way that it was accidentally connected incorrectly. That happens. Stuff happens. But all we have to do is put a SCSI chip on there. And then we've got Ron's PC compatibility board for the Apple II, or not for the Apple II, for the Mac, that we have figured out, fixed up. Stand by. How's my video look, by the way? This is a completely random connection, or random question. Is it okay? Video okay? Anyway, like I was saying, we got his board figured out. We got that cleaned up. We got the chip cleaned up. And all we have to do is get the stuff cured, scrape off the top layer of the stuff, of the solder mask, and get that resoldered, and maybe that'll work. Okay, Good. Thank you for telling me the video was okay. I'm looking at it in my preview window over here on the stream, and it It's like it's in crap mode, but I think it's in crap mode because I'm reviewing it while I'm streaming or something. Anyway, well, I think we had a lot of fun tonight. Thank you all for hanging out with me. It's been super duper fun. Thank you for all your chats and your questions, your comments, and your fun repertoire. Repartee? Witty repartee? Is that the term? Ron, thank you for stopping by and watching the stream. I do appreciate that. Thanks for sending this board to me to have something to fix. That's super awesome. For everybody who gave me a super chat or super sticker, if you're still in the chat, thank you for that. That goes to help keep this thing back here running, you know? Well, I think that's all we're going to say for tonight. Maybe tomorrow we will pick this back up. I don't know if I'll do that tomorrow. It might be Monday. I don't know. We'll see. And then we will go from there. So thank you, everybody, for stopping by, and you all have a great evening. Bye-bye.